There are so many pieces of the various technologies of Amazon Web Services. In this nugget, I wanted to just take a moment of Zen. Let's take a breather for a moment and let me just walk you through a sample AWS scenario and how some of these technologies might be used together. So we have developed this exciting, new, powerful web-based application. And this is going to have global reach, and we want the highest levels of availability. So one of the things that we do is we go ahead and we utilize two different regions of the Amazon Web Service global infrastructure. So we have a region in, let's say, Oregon in the United States, and then we do like Paris, for instance. Inside of these regions for deployment of our application, we know there are different availability zones. So I'll draw those in, and we are going to be making sure that we take advantage of those multiple availability zones. So we're going to have a further level of redundancy and high availability. So let's say that we put a web server in AZ1 and in AZ2. We have an AZ1 over here and an AZ2 over here, and we have these web servers. And we're monitoring using CloudWatch the utilization of these servers, and we discover that we need even more. So we put a few more in each of these areas. And then we decide sometimes they're not all needed. So we start doing auto scaling in both of these regions and in the respective availability zones. So now there's this automatic expansion and contraction of these resources. What about storage? Well, globally, we have the ability to have these S3 storage buckets, and we can have the files that we need for the website and files that the application might need stored in the S3 bucket. By the way, something clever about S3 is that you can use it to host a static website in and of itself. You don't even need to build web servers. You could have S3 host the website. Pretty cool. But in our example, we've got web servers that we've spun up in all of those different locations. By the way, we take advantage of the elastic load balancing capabilities so that we don't have one of these servers not having any traffic compared to another server. So we can balance the load using elastic load balancing across the EC2 instances that we are utilizing. We need administrators to help us with this global application that's kicking butt, and that's why we have the identity and access management tools so that we can create user accounts for those users. That is a very strange looking user. So we can have accounts for those users that give them the permissions that they're going to need to assist us with this application. As the application gets more sophisticated, we realize that it's going to need a database layer for storing of information. We look at the different database options and we decide that the RDS, the Relational Database Service of Amazon Web Services, is perfect. So we spin up in each availability zone the RDS implementation that we are going to need for database services. The RDS implementation is so great because the backing up of data is automated for us. So the Relational Database Service is being backed up automatically by Amazon Web Services. We can, of course, go in and do backups manually ourselves as well, but we feel protected with the Relational Database Service and the automation that Amazon gives us. So here's a look at how these various components might work together to bring a worldwide application out there to the masses. Don't forget that another underlying resource here that we have is our virtual private cloud technology. The availability zones in the region are going to rely on the virtual private cloud to do their work. Also, if users were to start complaining that our application access is a bit slow, one of the things that we could do is take advantage of what are called those edge locations. And with the edge locations, we can utilize something called CloudFront. And CloudFront will sit in the edge locations and it will do caching of frequently accessed data so our web servers aren't as busy, and it can deliver the content to the users that are close to the edge location right out of that edge location and minimize the latency rather dramatically. So CloudFront, another service we may want to integrate into this example. Note that when you build an application that's going to be globally distributed, there's going to be lots of moving parts inside of Amazon Web Services that you're going to call upon. The great news is that it is a modular approach, right? Having it be modular is going to increase our availability to control things. And if one component were to fail, it's not going to fail our entire design. Notice one of our virtual machines could die in this example, or the elastic load balancer could pause doing its work, and there wouldn't be a loss of access for our application as a whole. I hope you found this nugget informative, and I'd like to thank you for viewing. In this nugget, you and I are going to dig into some more details when it comes to pricing as associated with Amazon Web Services. Let's begin by covering some more details about the support plans. The Amazon Web Services support plans could be a big part of our budget when it comes to Amazon Web Services for our infrastructure and compute and storage and all those great resources. Recall that when we Google AWS support plans, we can go to this compare page and we know that there's the basic, the developer, the business, and the enterprise levels of support. Notice that 24/7 access to customer service is something that's going to be given to us across all of those 4 plans. So that's great. Also, Trusted Advisor is common between the levels, but we are going to be limited to 6 core Trusted Advisor checks when it comes to the basic plan, and the developer plan, we start to get to full Trusted Advisor capabilities with business and enterprise. Now, if we scroll down, a big differentiator is technical support, right? With the basic plan, we don't have any, and then developer, business, and enterprise are going to give us that 24/7 with the business restricted to email. So that's a key differentiator. Another big thing is if there will be specific individuals assigned to our account or not. For instance, when it comes to account assistance, notice we have the support concierge, and that's going to be restricted to the enterprise level of support. Just like what's called a TAM, or Technical Account Manager. This TAM functionality is great. They provide us proactive guidance on our Amazon Web Services, but that is limited to the enterprise level support contract. From a pricing standpoint, notice that we know we don't pay anything extra for basic support, but the starts at $29 a month is with our developer support level, then the business level starts at $100 a month, and then the enterprise level starts at $15K a month. So we want to think about these different services that are provided at each level, and also, of course, we need to budget for these support costs. Now, in our nugget on pricing models, we got into a little bit of the different ways that we can price things when it comes to EC2. Let's elaborate on that right now. We said there was on-demand pricing for EC2 resources, and this is the price that exists at a given moment in time. And when we spin up a certain instance type with certain software running through the AMI, we're going to be charged that price. We said there was a reserved instance pricing model that we could use, and we could pay none up front, some up front, or all up front in order to receive different discounts. This is going to be a 1 to 3 year contract, by the way, so this would only be appropriate if we were willing to commit to Amazon Web Services for those longer durations. Then there's something, though, that we haven't discussed much, and that is spot instance pricing. Let's say the current on-demand price is 48 cents an hour. We go in and we do a bid of 45 cents an hour. So this is called our bid price, and this is called the spot price. And let's say the spot price does fall to our 45 cents an hour that we're willing to pay. The EC2 instances will spin up at that price. Pretty cool. So an auction style when it comes to pricing is spot pricing that we could engage in. Something else that you can do if you're willing to pay extra is you can say that I want my EC2 instances to be on dedicated, gotta spell it right, dedicated instances. This is pretty cool. So now the hardware that's up at Amazon Web Services, that will be exclusive for your instances. So we know that we are not sharing hardware with other customers. You could see if security was of a major concern, we might want to look at dedicated instance pricing. Now, if we need to lock it down even more than that, we would go with dedicated host type structure. Here, not only are your EC2 instances going to be on dedicated hardware, but you'll actually know the specific hardware ID of that system. You can literally place it on the specific hardware and have an identifier for that hardware from Amazon Web Services. We would do something like this where we have licensing in place already that we want to use in the cloud, and that licensing must reference specific hardware that we're putting that software on. So that takes it even further, and again, don't forget, you would pay for those privileges. If you're interested in the certification exam that goes along with this course, we covered two areas in this nugget that are quite important. We took a look at the different support levels once again. Those would certainly impact your price with Amazon Web Services. And we also talked about the different pricing models that we get into with EC2. Remember, those were spot pricing, reserved pricing, on-demand pricing, and then dedicated instance and dedicated host pricing. Be ready in the exam environment to discuss what's available at the different support levels, and also be prepared to discuss the different EC2 pricing models and maybe even a scenario where you'd have to pick one. For instance, if we have a scenario that says we have this fixed workload that we need to run for the next 3 years, and we know there'll be no variation in that workload, well, this would be a great time for you to consider reserved instance pricing. This is because it's a long time that you want to have the resources. It's a fixed workload. You know exactly how many resources you're going to need. So that would really lean you towards the reserved instance pricing. Be ready for those types of questions if you're interested in certification. I hope you found this nugget informative, and I'd like to thank you for viewing. One of the most impressive areas, I think, with Amazon Web Services is your ability to easily automate things. Think about it. I mean, when you use the web console, you're clicking some buttons and stuff is automatically being built in the cloud. So that in of itself is automation, isn't it? If you use the command line interface and you run scripts, you can automate the creation of resources in the cloud. And then there's software development kits, of course, that we can use that use APIs to allow us to write software programs to automate in the cloud. So these are the three main ways in which we interact with the cloud, and those provide automation. But there is full-blown services that I want to show you that are going to bring automation even more to the capability that we have. And I'm going to show you some services that are all about very cool application support. When it comes to automation, the tool, and that's a capital T, capital H, capital E, is CloudFormation under Management Tools. This product is absolutely remarkable. What you can do is you can go in and design a template or use one of the pre-designed templates by Amazon Web Services, and then you can use this template to create a new stack. What is a stack? A stack is all of the resources that you're going to need in Amazon Web Services. So think about what you're doing. You're using a template designer to create this script, which is then going to create like your virtual private cloud you need, the EC2 instances that are going to live there, the S3 storage buckets you're going to need. Maybe you want to do some Lambda functions that can be contained inside of this template that drives the creation of all of this stuff. If you create one of these templates and then therefore one of these stacks in CloudFormation, you can then go in and delete the stack and it will delete all of those resources for you that was created using this tool. So the ultimate of automation tools in Amazon Web Services is CloudFormation. Now, as I indicated in the introduction, there are also services that are going to help you when it comes to application deployment. One of the ones we spoke of earlier was the Elastic Beanstalk product. Remember that? That's where resources for an app that you want to host would be spun up for you. But there are other options. One of them that is pretty cool is Code Deploy. So notice I just typed in code under the search area and Code Deploy is an option. And this is a tool that's going to allow you to upload your code and then have versioning on your code, for instance, and then deploy your code. This is one of the tools that you have available in Amazon Web Services that you might even use to deploy applications into your on-prem environment. So this and the next tool I'm going to show you are powerful in that the application that you're managing through AWS doesn't even need to be deployed into the cloud. You can deploy the app to other locations as well. So Cloud Deploy is one of them. And then another one that I wanted to highlight for you is called OpsWorks. So I do a search on OpsWorks and notice that this is a tool for the deployment of your applications. And this is designed to work with Chef or Puppet. Chef and Puppet are common applications now that are used for the management of applications and their deployment. And we can use these tools with OpsWorks in order to ease the deployment of our solutions. And once again, as I indicated, this could even be for the deployment of the application to your on-prem facility. Now, it's at this point that I need to give you some guidance because I know what you might be experiencing, and that is you might be a little overwhelmed. As we look at the services here, we need to know about EC2, we need to know about Lambda, we need to know about Elastic Beanstalk, S3, Glacier, we need to know about RDS, DynamoDB, Redshift. I'll stop. You get the idea. So in order to become a certified cloud practitioner, you're going to need to know about, from an overview perspective, many of the services inside of Amazon Web Services, and you can get a bit overwhelmed. One of the things that you might want to consider doing is creating flashcards on all of these services that it would be an excellent idea for us to know for this certification exam. You could do traditional index card based flashcards. On one side put the service, on the other side the overview, or you could even take advantage of many of the cool electronic options that exist for like mobile phones and your computer. When it comes to automating Amazon Web Services or supporting your applications, we know there are great tools we can take advantage of like Code Deploy, OpsWorks, and the ultimate automation tool, CloudFormation. I hope you found this nugget informative, and I'd like to thank you for viewing. A key to security with Amazon Web Services is access management. Who is going to be accessing the services of AWS and what privileges will they have? Let's take a look at that in this nugget. When you first sign up for Amazon Web Services, you create what's called a root account. And then Amazon says to us, please don't use that account. This is the godlike administrator account, and you don't want to use it. what you want to do is go into your Amazon Web Services, as you can see here, and go to the security section, and you're going to go to IAM. This stands for Identity and Access Management. So we go into this area, and you're going to notice something right away. There's these security status checks that you should go through. Let's run through them quickly. Delete your root access keys. So remember when I said they don't want you using that godlike root account that you create initially? Well, they want you to go in and they want you to make sure you delete the access keys for that account. And this is going to make sure that no one could breach those. You can certainly store those and secure those locally so you can occasionally use the root account, but you don't want them stored up in Amazon Web Services for no reason. Then we have MFA. On the root account, at the very least, maybe all of our accounts, we want to enable multi-factor authentication. In the exam environment, if you're interested in the exam, anytime you see MFA, that's multi-factor authentication, it might also be abbreviated MF for just multi-factor. What this means is we're going to need like our password and a code that we enter that is displayed on our mobile phone. So now we have to know something, the password, and have something, our mobile phone, in order to get in. We are going to create individual IAM users. We're going to create groups and assign them permissions, and we're going to put in place a password policy for these users. So notice what I did. I did a sample for you. I went in here under users and I created an Sequera account and I put it in a group I created called AWS admins. So here's our AWS admins group. And if we go to that group, we can see that there are permissions assigned to this group and it's full administrator access. Notice there's also roles in identity and access management. These are great. You can go in and you can create a role, let's say the ECS instance role, and you can give permissions to this role so that you don't have to necessarily create user accounts for your permissions. Let's say that we are going to have an EC2 instance, one of our virtual machines, need to access S3, the main storage service of Amazon Web Services. We can create a role that the virtual machine can use in order to make that storage access. So notice roles can often be the glue from a permission standpoint that will keep our services together. You can also go in and create sophisticated policies. So you could go and create a policy or pick from one of the built-in policies that's going to allow the exact permissions that you need. Notice also that we have the ability to connect the Amazon Web Service directory service to other directory services. So maybe we want to connect the Facebook user account system into the Amazon Web Service account system. This is possible thanks to our ability to create many different and connect to many different identity providers. Now, one more thing I wanted to show you in here is notice that there's this encryption keys area. Amazon Web Services supports all kinds of encryption. We can encrypt data in Amazon Web Services and have Amazon take care of all of the management of the keys. These are essentially passwords. We can have them handle all of that. Or we can do encryption of information in the cloud and we can handle all the password or keying information. So lots of excellent options when it comes to encryption and your cloud resources. So in this nugget, we took a look at identity and access management inside of Amazon Web Services. This is super powerful, and we're going to go in there after creating our initial root account, and we're going to create users. We're going to put these users into groups. We may end up utilizing built-in or create our own roles that allow services to interact with each other and have the appropriate permissions. I hope you found this nugget informative, and I'd like to thank you for viewing. Now, I certainly want you to keep in mind that I have an entire section of nuggets in this course dedicated to pricing and billing when it comes to Amazon Web Services. But in this early introductory nugget, let's just talk about an overview of costs when it comes to Amazon Web Services, and you can apply this to many competitors to Amazon Web Services as well with cloud technologies. Amazon Web Services reminds us that the overall economic model that we use when we sign up for their services is to simply pay as we go. And this sounds simple, and it is, but it is profound the impacts that this is going to have on you when it comes to the economics of your IT. So we sign up for initially a free account, and then we start building resources, and if some of these resources aren't covered in the free account, or if we go outside of the free account's duration, it's like a year or something that we're going to have the free tier. Once we're outside of that free tier, we're paying for stuff as we go along with that stuff. Think about it. This means that resources are suddenly entirely disposable for us. What a great thing. So we can go in and we can get rid of resources we might no longer need. And sure enough, we're not paying for those resources any longer. This really does have a tremendously big impact on us. And notice that it's going to help us compared to a traditional environment when it comes to the purchasing of our IT resources. Think about the two basic approaches that we can go. We can go in and we can over-provision things, and this is to make sure we can meet the demand. So we have these big servers, and unfortunately, they're probably running at very little capacity. We have a lot of idle hardware as a result of this over-provisioning. So we can do away with this approach thanks to Amazon Web Services and provision just that right amount of stuff that we need and pay as we go for that. Notice another approach that we could take in the traditional environment is we buy too little server power, and now we're always dealing with it being very close to capacity, and now we can get into performance issues. So we really like the fact that with Amazon Web Services, we have a consumption model that functions like a utility bill. It's like your electric bill. Want to save money? Start shutting off lights and TVs and computers that you're not using. Amazon Web Services works very much the same way. Now, I mentioned the Amazon Web Service free tier, and that is something that you can Google. So here I've done a Google search on AWS free tier, and I get brought right to this homepage where we can jump in and quickly create a free account. Keep in mind, though, that when you're in this free account, you may be spinning up resources that aren't covered under the free account, and you will be billed for those. But Amazon Web Services does a great job of letting you know when you're going outside of what's free. And let me show you how easy it is to see what those non-free things are costing you. So here I am logged into my Amazon Web Service account. Notice I can confirm that because my name appears here under the account dropdown. Notice also that we can see that we are in the Ohio region right now. So my resources are physically located in the US East Ohio region. If I drop down this little name area here for my account, I can quickly go to my billing dashboard, and I can see the details of what I'm doing that's outside of the free account and costing me money. Notice that last month I spent $17.33 on Amazon Web Service stuff, and this month so far I've spent $2.02. And finally, notice the forecast for December is given. So without configuring anything, we can quickly take a look at the costs that we're incurring on this pay-as-we-go model. I want to elaborate on one more thing here, and that's for you to realize that I am in the free tier. So I am still within the time duration of my free tier. as I said, why I'm getting these small charges is because I am doing things in Amazon Web Services that are not included in that free tier. So it's definitely something to be aware of. I will certainly have lots more great information for you on billing and pricing when it comes to Amazon Web Services, but I hope you agree that now we've got a good feel for the economics of Amazon Web Services and other cloud vendors. I hope you found this nugget informative, and I'd like to thank you for viewing. It is really true that when you move to Amazon Web Services, you can dramatically increase the security of your information technology. This is contrary to the myth that when you move to public cloud, you're in big trouble when it comes to security. Now, the thing is, understand that you don't get this increase in security without work on your part. We are going to have to follow some great design methodologies when it comes to ensuring we're doing the very best with our cloud security. Remember, there's the concept of the shared security model. There are responsibilities that we are going to have in addition to the responsibilities that Amazon Web Services is going to have within their cloud. So focusing on the stuff that we need to do, one of the things that's important is to realize that you're building things in layers, just like you would in your traditional data center. So you're going to have like your network infrastructure layer, you're going to have databases, you're going to have servers, you're going to have elastic load balancers. All of this stuff needs to be secured. So you want to make sure at every single layer you are adding the appropriate security. This gives us what we love, and it's called a defense in depth strategy. And the attacker may get through one layer, but then they may get stuck at another layer or another layer, and they'll inevitably give up. Once it is clear that you're doing defense in depth, many times they'll just give up and try another target that hasn't been built as securely as your own. Congratulations. Something else that we want to do with security is we want to build what's called traceability into absolutely every layer that we can. So if there is a problem, we can easily trace it back to the source and then begin patching whatever issues existed. Always use the concept of least privilege. We know that there is the root account, the godlike administrator, and that is an R, by the way, the root account, the godlike administrator of the Amazon Web Service initial setup. We don't use that anymore once we initially log in. We create an admin account that's godlike for our purposes, and then we create other accounts for ourselves that will give the least privilege that we need to do certain tasks. And we do this for our fellow administrators. We might have a network admin that we work with, and we give him, let's say, 3 accounts. One that gives him the level of access that he needs with databases and only that level of access. Maybe another one that gives him the level of access that he needs with storage. You get the idea. We're always going to be making sure that we are logged in with the least privileged user account that we need. We also need to remember that as the shared responsibility model goes, we need to do our part, and that is to really take our compute resources and secure them. If we're built on EC2 for compute resources, we need to make sure we go in and we patch the operating systems, patch the applications that are running when new security problems arise. Finally, always consider automating as much of this stuff as you can. That's really going to help you. Inside an operating system like, let's pick Microsoft's Server 2016 platform, there's a way that you can set it up to automatically security patch itself, and that's something that you would want to engage in to ensure that you are secured as best as possible in that operating system. By the way, it's not always that we want our servers automatically updating themselves, so use that recommendation from me with some caution. It might be your policy that you never allow servers to do that. You manually go in and apply the updates, and if that's the policy in your organization, obviously stick with it. Now, another important aspect of Amazon Web Services and security is compliance. What if we are working with patient health records? We are probably going to have to adhere to the standards from our federal government on properly securing this health information. We have to be compliant with the appropriate laws in this area. No problem. Notice there is a section of Amazon Web Services dedicated to this. AWS engineers will help you ensure that you meet the various compliance requirements. Oftentimes, we're able to do this with Amazon where we wouldn't have been able to do it on our own. So we can meet levels of compliance that were never before possible when we were working by ourselves. Something else to think about too is penetration testing. Can we do penetration testing against our stuff in Amazon Web Services? And the answer is a resounding yes, but you need their assistance at Amazon Web Services in order to do this. In fact, let me state it more clearly. You need their permission. You cannot pen test against your stuff in Amazon Web Services without obtaining their permission. And then, of course, they will be able to give you guidance, but that permission step is the key. So would it be possible to move all of your IT to Amazon Web Services and be more secure than ever? The answer is yes, it is possible. And can you be compliant with the appropriate laws and things that you need to be compliant with? Yes, you can. And finally, could you even engage in your own penetration testing against these resources to make sure you're doing a great job? Yes, you can, with permission. I hope you found this nugget informative, and I'd like to thank you for viewing. Now, I've got some great news for you. When you move to cloud technologies, you're not completely throwing out all the design principles and the blueprints and the best practices that you've used forever. No, you're probably going to use most of these in the cloud, but you will expand and you will have the ability to incorporate new and exciting design elements when you're designing and building architectures in Amazon Web Services. In this nugget, let's take a look at the areas of good design principles that we can use and even expand on some of those. Amazon tells us that when we want to engage in design for the cloud, we should break it down into these 5 different areas. We should consider security design principles. We should design for reliability. Reliability means not only just is the resource there, that's more availability. What reliability means is the resource there, but also performing the way it should. And that leads us to the next design principle area, and that's called performance. Is it performing beautifully? And then cost optimization. And finally, the operational characteristics of what we are designing. Are these functions that we have in the cloud operating the way we need them to operate? You'll often refer to these, and you'll hear Amazon do so, as the pillars of great design for our cloud. Now, I'm going to elaborate on security when we, of course, delve into security in this course. I'll elaborate on cost optimization when we do pricing and billing. So let me take a moment and delve into the world of reliability, performance, and operational design characteristics with you. When it comes to that reliability pillar, we want to think about things like, how are we going to test reliability? If we were to have a resource fail, for instance, how long does it take for a new resource to take its place? This is measuring what we call the fault tolerance of our design. Can we automate the fault tolerance? Can we automate the recovery and therefore the reliability so we don't have to manually go in and implement a new resource? Also with reliability, we start scaling horizontally as Amazon Web Services would recommend. So with Elastic Compute Cloud, for instance, where we are going to have a virtual machine, we don't want to consider really just building bigger virtual machines. Instead, what we can do is use smaller virtual machines and scale them out horizontally. One of the things, too, under the reliability pillar is the fact that we'll no longer have to be guessing at capacity that we need. We know that we can spin up resources on demand as demand increases, so we can eliminate that guessing game. Automation, as I indicated, is a big part of all of this process when we're designing for reliability. And something else that you want to consider in reliability is change management. Since Amazon Web Services makes it really, really simple and gives us that speed of change that we might be looking for, this can cause another issue, and that is that you're changing so fast you can't keep up with it. So how about the pillar of performance? What kind of good design characteristics can we do there? Well, one of the things that we can consider doing is democratizing advanced technologies. What does this mean? This means fancy speak for we're going to be able to take advantage of technologies like artificial intelligence that we never thought we would be able to take advantage of before. So always be pushing the limits with the accessible technology that Amazon Web Services makes possible. Something else that's great from a performance perspective, and I'll elaborate on it in its own nugget, is the global reach of Amazon Web Services. In the first 11 years, or the first, let's say, 10 years of Amazon Web Services, they were able to create 11 different regions across the globe. Now, in the next 3 years, they'll be creating 11 more. So they are so rapidly increasing the number of regions they can service around the planet, and that can really help us with performance because we can locate resources right near our customers. Serverless computing is super popular, and we have a service called Lambda that does this for us, so that's awesome. We don't need to spin up servers to get compute resources anymore. Remember, we can experiment very easily in Amazon Web Services. That can help us with performance. And finally, with Amazon Web Services, we can engage in something called mechanical sympathy. This is such a fun expression. There was a race car driver who said, and I very loosely paraphrase, the race car driver said, you don't need to be an engineer to be a race car driver, but you should have mechanical sympathy, meaning you should understand how the car works. Well, this has to do in tech with software developers understanding the hardware and designing with the hardware in mind. And Amazon Web Services makes that very simple to do. So the last one I wanted to elaborate with you on in this nugget is the operational pillar. And things we can do here is, once again, make sure we are managing changes and even automating changes that we need to make in our infrastructure, making sure that we have a great response time to problems, for instance, that might exist in our infrastructure, and finally, designing to the standards, the best practices that Amazon Web Service makes available to us so that we can ensure a great operational performance of our resources. So when we engage in excellent cloud design, we're doing it around the pillars of security, reliability, performance, cost optimization, and operational design considerations. In this nugget, we expanded on the operational, the performance, and the reliability pillars. We'll look at security in more detail later on, as well as cost optimization. I hope you found this nugget informative, and I'd like to thank you for viewing. It's great that we can store things in the cloud, for example, but at some point we're probably going to want compute resources in the cloud. Maybe we're hosting a website and we want the web server to be completely in our control, so we want to spin up a web server in the cloud. Maybe we're going to be hosting a SQL Server database in the cloud and we want complete control. So we want to spin up a Windows Server 2016 system, for example, and we want to install SQL Server on top of that and control everything. These are some scenarios of the many that we can accomplish thanks to compute services inside of Amazon Web Services. When you're looking at your services in Amazon Web Services, notice that there is a category called compute. And the very first entry is the foundational compute service that we're so accustomed to with AWS. It's Elastic Cloud Compute, or EC2. Notice when you go there, you start at your EC2 dashboard, and I can see that I have a running instance going right now. Its name is Management Linux, and I can get details on it right down here under the description area. It's running on an instance type called T2 Micro. What this means is it's got very little hardware resources dedicated to it. So a little bit of RAM, a little bit of CPU power. This is great for just a little management Linux box, which is exactly what I wanted it for. But you can go in and you can choose the launch instance and you can create something entirely more sophisticated. So we could go down and launch like a Windows Server 2016 base image and then install SQL Server on top of it. Or you could go over here to the AWS Marketplace and you could find someone that's already created that EC2 instance for you, the SQL Server installed already, and you could take advantage of that EC2 instance. But what's really exciting lately, if we go back to the main services page, is Lambda. Why Lambda is so exciting is because you don't even need to run servers. You don't need to spin up those EC2 instances. Instead, what you can do is have some event trigger. Maybe like we upload something into an S3 storage bucket, and based on the fact that something just uploaded, that's called a trigger, we can send that trigger up to Lambda and have Lambda do some type of compute function. Maybe we want to create a thumbnail image for the JPEG that we just uploaded into the S3 bucket. No problem. We write what's called a function inside of Lambda that will be triggered with the JPEG upload, and it does the compute for us, and we don't need to worry about any of the EC2 instance spin-up. Serverless cloud computing is the rage, and Amazon Web Services with Lambda and Microsoft with Azure, there's lots of different cloud vendors now that are starting to implement this. Another really cool compute resource that you need to be aware of as a cloud practitioner is called Elastic Beanstalk. What this is more automation for us. Your application developers, they want to take advantage of using the Amazon Web Service Cloud to deploy their applications, but they don't want to be caught up in the gory details of building servers and networks and firewalls and load balancers and all that stuff. So they can come into Elastic Beanstalk and they can quickly select a platform, upload their application, and that's it. They are now fully implemented with cloud. This automates the creation of all the underlying components that this application developer would need inside of Amazon Web Services. So this is automated. They just choose what platform they want, then they upload their app, and that's it. It's really amazing. Now, something I want to discuss with you that is done automatically in this process or manually that we would have to do is when you're going into, let's say, EC2, and let's say you spin up a web server, one of the things that can happen is you can quickly outgrow that web server. So maybe you want to spin up 3 web servers, all containing your website. Now you need a way to load balance between them. And as you can see right here inside of our EC2 options, if you scroll down, there is a load balancer option. So we have the ability to also spin up a load balancer inside of Amazon Web Services, and this will take requests of that web server that you're getting, and it can distribute them across your different web servers. Notice that we can do a network load balancer or a more sophisticated type of application load balancer, but the end result is the same. A lot of different client requests can be distributed across your different compute resources automatically by the load balancer. So that certainly was a lot of information. Let's review it real quick. We have lots of options when it comes to compute resources inside of Amazon Web Services. We know, for instance, we have EC2, which allows us to spin up virtual machines inside of Amazon Web Services with the software that we need. But if we want to go serverless, we have Lambda. Lambda allows us to not even spin up any servers and still get compute functions done. Our developers may want to take advantage of Elastic Beanstalk, and that'll allow them to have all of this EC2 and load balancer and network stuff created for them so that they can just upload their application. And finally, we also took a look at elastic load balancing inside of Amazon Web Services. We know we can do it kind of classically, what is called network load balancing, or we can do a more sophisticated variation and load balance based on different applications that we're running. I hope you found this nugget informative, and I'd like to thank you for viewing. Welcome to the AWS Certified Practitioner course here at CBT Nuggets. My name is Anthony Sequeira, and I am so thrilled that you're joining me for this introductory look at Amazon Web Services. We're going to get pretty deep, though, into the various services, the billing and pricing that we have with Amazon Web Services, and of course, why Amazon Web Services is so compelling. Now, one of the really awesome things about this course is if we go up to Google and we do a search on Amazon Web Service certification, and you go to the first official link right here, AWS certification. So notice it's not an ad. And we go to this certification area, you'll see that if we look at the certifications of Amazon Web Services, and you can scroll down to see the certification roadmap, you're going to find that a great AWS certification maps to this course. It's their new foundational level of certification, and it would apply if you want to become a cloud practitioner. In fact, it would be the only certification you would take if you wanted to stop there. But if you're interested in the different tracks like architect or developer or operations, this course is going to serve, and the certification exam will serve as a perfect foundation for you to get started on those different tracks. To give you complete coverage of everything that exam might contain, and also to give you a great head start in the world of AWS, I'm going to break this course down into 4 main areas. So our nuggets or videos will be focused around cloud concepts, things like what really is AWS, and what is the economics of the cloud that makes AWS so exciting. We'll take a look at many important security topics, including very important resources that Amazon Web Services makes available for us that you're going to want to be aware of. Then, by far, the largest part of this course will be the Amazon Web Service technologies themselves. We'll break this down into compute resources that are available for us, network resources, of course, security resources, database resources as well, and we'll even take a look at some of the monitoring capabilities that we find in Amazon Web Services. And we can't leave out the storage capabilities that we find in Amazon as well. Finally, we'll wrap up this course with a look at some nuggets centered around the important topic of pricing and billing. After all, while cloud is super exciting and brings many advantages to us, we have to be able to afford those advantages. So are you excited to get started in the Amazon Web Service Certified Practitioner course? I bet you are. I know I am. So let's do that, because as I indicated, we have some nuggets to deal with that are really going to define Amazon Web Services for us and get us really excited, if you're not already, about taking advantage of these cloud technologies. I hope you found this nugget informative, and I'd like to thank you for viewing. Databases? We don't need no stinking databases. Wait a minute. Of course we do. Databases are a key facet of our IT infrastructure, and this is another area where Amazon Web Services shines. When we visit the Amazon Web Services, notice that there is a category for database. And of course, the first one listed is going to be the foundational service in that category. And that is RDS, which is the relational database service. So let me say, no, I don't want to provide feedback right now. And if you choose Get Started Now for RDS, notice what happens. They will assist us in spinning up a MySQL database, a Maria database, a Microsoft SQL Server database, an Oracle database, a Postgres database, or a very important option here is Amazon Aurora. This is their own flavor of relational database that they have developed. So be aware of these options, especially Amazon's own option of the Aurora database inside of RDS. But what if we want to do different type of database work? What if we don't want this structured SQL-based database technology? Well, there are other options. If you go back to services, notice there's DynamoDB. This is a very exciting non-SQL database service, and this is going to be lightning fast. It does a lot of the content caching of the database contents right in memory to be uber fast. We're talking millisecond type retrievals of information. Notice this makes it great for things like mobile and gaming and web and Internet of Things type of storage. So when it comes to non-SQL databases, the DynamoDB is an exciting option. But there's another very important area of databases today, and that is big data. What about storing massive amounts of information that you want to then extract important, valuable information from? An example of big data at work would be like taking every single one of the tweets that mentions your organization and taking all that massive amount of data if you're a big company and then gleaning information from all those tweets about your company. Well, this is big data services inside of Amazon Web Services in the form of Redshift. Please know this term and this service. Amazon Redshift is the data warehousing solution, and this service interacts with some well-known open standards for data warehousing. So you're not going to be just working with your own standards when it comes to the data warehousing. You can leverage open standards for this technology, and you can do big data stuff with Amazon Web Services handling for you the extremely complex task of storing and then making readily available those massive quantities of data. Now, something that comes up a lot for Amazon is customers that say, wait a minute, I've got my database just perfect on-prem, on-premises that is, and they want to just move that database up to the cloud. Amazon has gotten this request so many times that they developed a service around that. So from the main services page, if we scroll down, you'll notice that there is an area just dedicated to migration. There's Snowball. This is super interesting. This is where you're taking just data that you're storing and want to move it to the cloud effectively. But notice there's one that would interest us in this nugget, and it's DMS, the Database Migration Service. So this is going to help you take your existing on-premise database and migrate it to one of these excellent cloud-hosted solutions with Amazon Web Services. While the database plays a critical role in us storing information in the cloud, understand that in and of itself, it's not going to do much for us. So Amazon Web Services also makes it very easy for you to have EC2 instances go and grab stuff from your database, just like they would make it easy for you to back up the important information in your database and even make your database storage close to where the users are that want it. So maybe we have a key database that's in France, and that's because the people that need this database are located in France. Amazon Web Services is very, very powerful for us when it comes to storing data and data that's housed in databases. I hope you found this nugget informative, and I'd like to thank you for viewing. In this nugget, let's think about what Amazon Web Services is and what is so exciting about it. Now, one of the exciting things about it, I should say, is that we can save a lot of money over traditional IT infrastructures, but I'm really going to table the discussion of economics for another nugget that's specific to that when we talk about, defining AWS. So let's forget dollars and cents for a moment, and let's instead just think about the characteristics that make AWS exciting from a technology perspective. We're going to cover a bunch of terms that really define cloud computing and Amazon Web Services, and one of those terms would be internet-based or internet accessible. And here you can see that I am using what's called the management console of Amazon Web Services in order to get to Amazon S3 storage services. And inside there, I can see a bucket that I've created called AJS Networking Photos. And if I go in there, there's this miscellaneous Dropbox folder. And if I scroll down, I can see that there are JPEGs stored in there. If I go to this JPEG right here, I notice that there is a link to access this JPEG out of the S3 storage facilities of Amazon Web Services. And if I click that link, it pulls up that image for me out of that bucket. So this is internet access to services and resources. And notice that it's on demand. When I need this stuff, I can get to it. So on-demand and internet-based access are two characteristics of Amazon Web Services and cloud computing in general. Now, other terms that we love to describe cloud, and particularly AWS, would be agility, scalability, elasticity, and performance. Let's take these two first because they're fairly easy to understand. We'll start with the easiest. When it comes to scalability, this refers to increasing the amount of IT resources you would have as demand increases. This is obviously something we would seek to have, great scalability. But elasticity goes even farther than that. As you can see, elasticity deals with scaling up and scaling down, or in specific Amazon Web Service terminology, scaling out or scaling in. And this is a great thing because we can have our resources not only grow and scale out as demand increases, but also contract and scale in when there is less demand. And I know I'm not supposed to talk about money in this nugget, but think about what this could do to our spending on IT resources. Something else that we love is the fact that we have great performance when we move to cloud technologies. Oftentimes, we can take advantage of compute horsepower that we would never be able to provision ourselves. Think about something like artificial intelligence. The compute horsepower that it takes to do AI might be something we could never before think of achieving, but now that we can access these resources in the cloud, no problem at all. Now, when we talk about cloud technologies and Amazon Web Services making us more agile, I like to break this down into three characteristics that really do this for us. Number one is speed. No, I'm not talking about that old movie where there's a bomb on a moving bus that they can't stop. I'm talking about the fact that we can more quickly get services out to our customers than ever before, leveraging all of the great resources of Amazon Web Services and the expertise of the engineers that design that for us. We also tend to have a culture of innovation when we do Amazon Web Services. Think about the AI example. We may have never thought about trying to get involved with machine learning and artificial intelligence before, but since these are services that are available to us in Amazon Web Services, we might start to think about innovation that way. And then the other characteristic I love that gives us agility is the fact that we can easily experiment when it comes to Amazon Web Services and new technologies. You see, you can spin up an infrastructure inside the Amazon Web Service cloud, and it's temporary, it's disposable. You can then delete everything that you created after the experimentation is done. Oftentimes, we don't have such flexibility, such agility in our on-premise data centers. Now, I thought it would be fun to wrap this nugget up by just giving you a little bit more detail about a couple more specific Amazon Web Services that are integral in making all this possible. By the way, remember, one of the web services that we looked at in this nugget was S3. This is object-based storage. But two more specific technologies I want to plant in your mind right now are going to impact performance dramatically, as well as agility and scalability and elasticity. And those technologies go hand in hand, and they are auto scaling, if I can spell that right, and ELB, elastic load balancing. These two services are critical for us. Auto scaling allows your compute resources to scale out or to scale in to give us that elasticity. And elastic load balancing will take compute resources that you might have spun up in the cloud, and it will load balance the traffic across those different resources. So in this nugget, we did discuss 3 specific Amazon Web Services, and we'll be discussing many more as we go out through all of the nuggets that make up the Cloud Practitioner set. So we love the agility, we love the on-demand internet accessibility of Amazon Web Services and its characteristics of elasticity and scalability and high performance. These are all critical aspects of cloud computing today. I hope you found this nugget informative, and I'd like to thank you for viewing. In this demonstration nugget, I'm going to show you just how easy it would be to deploy and operate a resource in a part of the world where you might have a lot of customers that need that resource. We know that one of the key resources of Amazon Web Services is the elastic compute cloud, the availability of virtual machines in the cloud for our use. Now you can see the EC2 dashboard here is displayed, and I have one running instance. I have one virtual machine running in the North Virginia region. I'm going to pick a new region because I want to show you what this would be like from scratch with a default Amazon Web Service configuration. I'll pick a region that I've never used before. In fact, it's a brand new region as of the week I'm recording this class. So we'll go to Paris. I've always wanted to go to Paris, so this is kind of fun. I feel like I'm actually going there. So I switched to the Paris region, and we're going to see the EC2 dashboard, and look at this. No running instances, no dedicated hosts, no volumes. The only thing they've done is given us a default security group. That's it. So let's launch an instance. We'll see just how easy Amazon Web Services can make this for us. So here on the step 1, we're going to choose an Amazon machine image, the software that I want to run. I would love to build a Windows Server 2016 base system in Paris that I can then install maybe an application that my clients there in Paris need. So I choose Select on the Windows 2016 server. They pre-select for me something that would be free, a T2 micro instance that'll be totally free. I get 1 virtual CPU and 1 gig of RAM. Awesome. I'll choose Next to the instance details, and we say, all right, we're going to spin up one of them. It'll be in our default virtual private cloud. There'll be no preference as to the availability zone we use. We will have a public IP address automatically assigned. Notice we can just skip all of this, accepting the defaults, and go to the next option of storage. I can say a 30 gig SSD drive will be fine. We could add tags to help identify this instance. And one of the things I'll definitely do at the very least is give this a name, and we'll just say Paris-test. and then I'll say configure the security group. They offer to create a new security group for us, and they offer to add RDP, the remote desktop protocol, as the permitted inbound way that we're going to communicate with this system. Sounds great to me. And I will name this Paris test so that I know what I'm dealing with here when I go to delete all these resources after the demonstration. So that's it. We'll choose review and launch. It warns us that we didn't lock down our security group by IP address. Okay, I'm fine with that in this test. We choose the launch button. It says you need a key pair in order to interact with this for security. We'll create a new key pair. The key pair name will be, surprise, surprise, Paris test. And we will then download this key pair to our local system. So I'll save that key pair on our system, and we will choose launch instance. That's it. Notice I added very little specifically as I was flying through the wizard. It's that simple to build a Server 2016 Windows system in Paris. How amazing. Now, of course, we're going to need to connect to that resource in order to further configure it, put the application that we want to host on it, all that great stuff. So notice I can click on this hyperlink right here to actually see the instance in Paris that we have spun up. And I notice that its instance state is running now. That's a great sign, and that happened very quickly. I should be able to connect now. Notice this instance is selected, and I have this connect button. When I choose the connect button, it says, hey, we'll help you out. We'll give you a remote desktop file, an RDP file that we can use in order to access that resource. This is the remote desktop protocol, and they're giving us the little file that we'd need just to double click and launch that. Wonderful. So I save that, and then it says to log into that instance, you're going to use the username of administrator, and we're going to get the password for you right now. But in order to do that, you need to provide that key pair that you created when we initially spun up this instance. So I'll choose the browse button, and in my downloads folder, we downloaded that Paris test key file. So I'll say open that. So it shows us now in this window our key, and we can now decrypt the password. So there is the big, long, complex password that was created so that we can log in to this device. All right, well, we're ready to see if all of this worked. What I'll do is just go over to my Windows Explorer, and there's that RDP, Remote Desktop Protocol file that we downloaded. I will double click it. And it says, are you sure you want to connect to this device over the secure remote desktop protocol session? We're not quite sure who this device is. We say, yep, we're sure. And we choose connect. And now it's ready for the password. That password was long and complicated. Let me copy it to the clipboard. And then let me bring back up our connectivity window. And I will paste it in and say, okay. And it says one more time, are you sure? We can't verify who this is you're connecting to. I say, yes, we know, we want to connect. And if this worked, we're going to be logging in to our brand new shiny Windows Server 2016 system that is located in Paris. And you can see it is working beautifully. Let me resize this window so we can see more of what's going on. Look at this. We are at the desktop. Here's the start button of that Windows Server 2016 base system that we created. And we can start interacting with this system in order to configure it and make the resources available to that region of the world where this EC2 instance lives. Notice also that while this is great for low latency access for those in that part of Europe, this is a resource that would be globally available. Here I am in the United States accessing our brand new server that is located in Paris. In this nugget, we got a glimpse of just how easy it's going to be to deploy and then operate a resource inside of Amazon Web Services. Remember, In this demonstration, we built an EC2 instance, a virtual machine. In this case, it was Windows Server 2016. We put it in a specific region of the world. It's living in a virtual private cloud in Amazon Web Services. And another key component that we saw was a security group, which is going to control access in and out of that compute resource. I hope you found this nugget informative, and I'd like to thank you for viewing. I always feel like someone is watching me. That's got to be how Amazon Web Services feels, because throughout the product there are awesome monitoring capabilities that we have. Let me tour you through these monitoring capabilities, just some of them, of course, in this nugget. It's important to realize that there is built-in monitoring capabilities for almost every service that you have in Amazon Web Services. If I go into Amazon S3, for instance, and I have my AJS Networking Photos bucket, notice that one of the things that we have is the ability to go to management, and there is all kinds of tools that we can use to help monitor and manage this bucket. One of the cool tools is analytics, and another cool tool is metrics that would allow you to literally see how much bucket size per bytes per day is going on for your storage. Now, the tool that is underlying many of these metrics is called CloudWatch. Let me show you. If we go to services and I go to EC2, another popular service, as you know, and I go to running instances, here I have this management Linux instance running. And if I go down to this bottom results pane and go to monitoring, we're seeing all kinds of cool metrics here about the utilization of this virtual machine. And notice it is CloudWatch that is giving us these metrics. If I go and click on the hyperlink for CloudWatch, we'll go into the CloudWatch tool and notice that there is all these metrics for this account under billing, the elastic block storage, the EC2, the S3, logs themselves. So CloudWatch is putting its tentacles, if you will, of monitoring into all the different services, or many of them, and giving us great monitoring metrics. And we can even pay additional money to Amazon Web Services to do advanced CloudWatch monitoring of our services. But by default, we're getting a basic level of subscription inside of Amazon Web Services. Great stuff. But what if you wanted to take your monitoring to yet another level? Notice that the EC2 metrics that we are monitoring are for things like memory usage and CPU usage and network bandwidth and things of that nature. But what if we wanted to monitor specific API calls to these resources? In other words, someone goes in and changes the configuration of one of our EC2 instances. Notice CloudWatch wouldn't monitor something like that. Not a specific API call to the EC2 resource. So what do we have for that? The tool we have for that, I'll go back to services and I'll do a little search for it, is called CloudTrail. CloudTrail is to track user activity and API usage, as it says here, and this allows us to really play with power as far as what our Amazon Web Service engineers are specifically doing to resources that exist in the cloud. CloudTrail goes more with security than it does with performance monitoring. For example, performance monitoring is CloudWatch, 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 where CloudTrail gets more into like auditing events that are taking place, and we may be interested in that from a security perspective. So the two big stars of the show as far as monitoring AWS goes are CloudWatch and CloudTrail. Know these tools, an overview of these tools, and know the key difference between them, which of course is one is focusing on performance metrics, while the other focuses on API calls and events that are transpiring against your resources. One is more of the classic monitor, that's CloudWatch, while another is more of an audit tool, that's CloudTrail. I hope you found this nugget informative, and I'd like to thank you for viewing. The AWS resources that you create can't exist in some kind of a magic vacuum. They need to live in a network. And that's why we have network services available to us in Amazon Web Services. Something else is that users around the globe need to be able to find your resources. We'll show you how that's done as well. When you create your root account in Amazon Web Services, they do something for you that's pretty clever. They build you a network. If we come in here to the list of services and you go under networking and content delivery, notice the very first entry is VPC. This is your virtual private cloud, and they build one for you. So here I am in the Ohio region, and you can see that I have one virtual private cloud. So this is a network that they have built for me. If we select it, we can see a summary information about it that's shown below. My block of IP addressing is 172.31 with a 16-bit subnet mask. So they have a block of private addressing for me to use inside of this virtual private cloud. Now, think about it. With the VPC, if I go back to the dashboard, we need to be able to get out to the internet. So sure enough, they've given us a pre-built internet gateway that allows resources inside of the virtual private cloud to get out to the internet, and could potentially allow our clients out on the internet to access resources inside of our virtual private cloud. So this is great that they are building the network for us so we can quickly get up and running, sharing things on the internet. But wait a minute. Let's say we have a web server inside our virtual private cloud. How would users out on the internet get to that web server? Well, sure enough, they would use what's called DNS, the domain name service. They would go to their web browser and they would type in like www.ajsnetworking.com, and we need that to resolve to the IP address that's in use for our web server, specifically the public IP address that's available for our web server. First of all, Amazon Web Service gives us this cool feature called elastic IPs. So we can go in and we can allocate an elastic IP address that will be publicly accessible for these clients. But we still haven't solved the problem of resolving that IP address to a publicly accessible DNS name like ajsnetworking.com. Well, sure enough, Amazon Web Service gives us a DNS service. So if we go up to services, and once again, we go to the network and content delivery area, there's Route 53. Route 53 is the DNS infrastructure for Amazon Web Services. You can go in and register a domain. You can manage your DNS. You can even do traffic management and monitoring on these built-in DNS services. So from a networking standpoint, you're given everything you might need to quickly start deploying resources out to your clients that are all over the globe and that are accessing the public internet for these great resources. So there are two main network services that we took a look at in this nugget, and that is the virtual private cloud, the very backbone of our network presence in Amazon Web Services. And then we took a look at Route 53. This is a built-in, easy-to-use DNS service within Amazon Web Services. I hope you found this nugget informative, and I'd like to thank you for viewing. We're pretty impressed at this point with Amazon Web Services. And what if it were free? Well, actually, that is how some of it works. We know we can sign up for a free tier, and we can use that free tier for a certain time period. And then, believe it or not, some of the services will remain free, potentially forever. So that's pretty cool. But let's face it, when we really start doing a lot of compute and networking and bringing in all kinds of services, eventually we're going to be charged. In this nugget, let's talk about how some of these pricings work inside of Amazon Web Services. So when we start using more robust services, more robust resources, we are going to be charged, and you can basically break it down like this. Of course, we need to be charged for compute. So when we go into EC2 as an example, and we start spinning up very large instance types, maybe we have something that uses like 34 gigs of RAM and it's got 8 virtual CPUs. When we spin up a beefy server like this, we're going to be charged per hour or per minute for usage of that resource. Think about storage. Sure, there's some S3 storage that will be free, but once we go over a certain amount of storage, we start getting charged. Something else that we're going to get charged for is data transfer, but in general, please keep this in mind, it is outbound data transfer, if I can spell that. Woo, I got it. So data transfers out are what Amazon Web Services will start tracking and charging us for. This makes sense, right? This refers to that stuff that our clients are accessing from Amazon Web Services. So when it comes to there not being a charge, that would be us like moving data into the cloud, or maybe us connecting to configure the cloud. These data transfers are not going to incur charges. And there's another interesting one that we don't get charged for, thank goodness, and that's, let's just say, transfer between. Now, what do I mean by that? I mean, like, here's our S3 service in the cloud, and this is our EC2 service in the cloud. When these two services are communicating with each other based on maybe some application that we're doing, in fact, maybe this is a web server and the S3 storage service has the web pages that we're serving up. This transfer right here we wouldn't be charged for, and that's a really good thing, of course, because we wouldn't want to start getting outrageous charges just because we're building our cloud the way Amazon Web Services suggested we build it, and that's separate and keep things modular and also use different availability zones so that we have good high availability and high reliability. Now, I've mentioned this before. The overall pricing scheme of Amazon Web Services, Amazon tells us, is a pay-as-you-go model. And that's really true, isn't it? If you go in and you spin up a bunch of resources that they're going to charge us for, at the end of the month, you get your bill. So we are paying monthly as we go with our Amazon Web Service infrastructure. Contrast this to what you would do if you built your own data center. If you built your own data center, that's a data center. Oh boy, I need to go back to Amber Barker's drawing classes. She's our illustrator here. Anyways, if you build your own data center, what do you have to do? You do all those associated costs up front. You're not paying as you go. You're typically paying a whole bunch up front, and oftentimes we have to guess at the capacity we need. Yuck. Notice something else about Amazon Web Service pricing, though. We get to pay less when we reserve. If you know that you're going to need 4 different big servers and that you're going to have these on all the time, you can do what's called reserved instance pricing, and you will save a ton of money. There's even 3 pay models there. You can pay all up front and you'll save the most money. You can do some up front and you'll save not as much money as you would if you did all up front. And then finally, you could do no up front and you'd save less. But all of these models are going to save over what the classic pricing scheme is, and that's called on demand. If you spin up these 4 servers you know you need just willy-nilly, then that's going to be on-demand pricing, and you're going to pay whatever the cost is at that time, and that will guaranteed to be more than if you reserved instances. Also, with a lot of the services, the more you start using, the less the price is per unit. Now think about that. Makes sense, right? I mean, obviously your spending is going up overall because you're using a lot more, but at least the per unit price is coming down for you as you become bigger in Amazon Web Services. And then finally, Amazon also does something cool. As they grow and as they make more money, they will pass those savings on to us. So we have seen over the years the average cost of resources in the on-demand model just continuing to go down because Amazon Web Services just continues to be much more successful. So we really need to study up on the costs associated with Amazon Web Services. And of course, I've got some more nuggets for you on that are going to help you, because while we can save a ton of money over traditional IT infrastructures, it does require us to do our homework and understand the various pricing models we've discussed when it comes to AWS. I hope you found this nugget informative, and I'd like to thank you for viewing. In this nugget, you and I are going to look at some awesome tools when it comes to billing and overall pricing support. Let's get started. Should we even move to the cloud? And if we do, how much money would we save? Well, that's the job of the Amazon Web Service Total Cost of Ownership Calculator. Notice I've done a Google search here on simply AWS TCO calculator, and you're brought to this page. And the great news is we don't have to sign into the console to use this tool, because let's face it, we might want this tool without an Amazon Web Service account yet. So notice we can launch the TCO calculator, and what you do with this is you just fill in a form and you'll get some pretty impressive results back. So we're thinking that we want to compare our on-premise traditional environment against moving to the cloud. So let's say that the region that we're going to be working with is in US West Oregon, and the workload type that we're going to be doing is general, and we currently utilize physical servers, and we're going to provide some information about that. So we're doing non-database server types, let's say. I will just put in an app name of test, and we're doing one processor per server, let's say. Let's say it's a quad-core processor, and we have, let's say, 12 of these machines, and they each have 32 gigs of RAM. So you get the idea. We provide information about our physical servers that are on premises, how much storage we have. Let's just say it's network attached storage, and we've got 20 terabytes total. So we put in this information, and then we choose Calculate TCO, and it goes to work looking at the cost estimates for our on-premises and then comparing that to Amazon Web Services in the region that we specified, which was Oregon. So look at this. We could save $173,000 over 3 years, according to Amazon Web Services. That's 61% a year. And then they break that down for us. The total cost of on-prem versus Amazon Web Services. Notice over 3 years with AWS, for the appropriate workloads that we provided information about, we'd spend about $60,000 on server, $48,000 on storage, nothing on the network, nothing on IT labor. And you can of course, go in and manipulate the assumptions that Amazon Web Services used in order to give you this information. But they give you all kinds of great breakdowns here, and this could be a valuable tool, of course, in your tool belt as you're making key decisions about on-prem versus cloud. Now, another great tool that you have at your disposal is called AWS Organizations. And what this allows you to do is combine management across multiple Amazon Web Service accounts. So let's say your company has a root account that was created by one of your key IT personnel and a root account that was created by another key IT personnel member, and you want to be able to manage these together. And one of the areas you would want to do that, of course, for is billing. There's a consolidated billing capability so that you could combine the EC2 resources from one account with the EC2 resources from another account, so you would have the accurate cost of all your EC2 resources. Consolidated billing and AWS Organizations are to the rescue there. Remember as well that when you're in Amazon Web Services, you never need to guess about the kind of money that you're spending. That's because if you go up to your user account and you go to My Billing Dashboard, you'll quickly see information about what you're spending with Amazon Web Services. There's even a cost explorer that you're going to have free access to that will allow you to analyze your spending and download the results or bookmark key reports about how you're spending in Amazon Web Services. And something else that you may want to take advantage of is notifications that are built right in. So here I am at my cost dashboard, and if you scroll down, notice there's an alerts and notifications area, and I have set up a billing alert. I've gone in and said, okay, Amazon Web Services, please send me an alert to my email if the estimated charges go greater than $20 within a 6-hour period. So basically what this is going to do is anytime it's looking like I'm going to be spending more than $20 a month on my Amazon Web Service account, I get a nice email alert about that. And we could configure as many of these as we need, of course. So there are wonderful resources for billing support when it comes to Amazon Web Services. We should never have sticker shock when we get the credit card bill for our Amazon Web Service account. I hope you found this nugget informative, and I'd like to thank you for viewing. No matter how proficient we become with Amazon Web Services, there are some areas where we might need to lean on the expertise up at Amazon. And one of the things that's great is we're going to have plenty of resources around various areas. One of those areas is certainly security, since it's so imperative and it can be fairly complex. So one of the first things that I want to discuss with you here is getting support from Amazon Web Services. Notice that I've done a search here on AWS support plans in Google, and the very first link is from AWS, so we can trust it. And when we go to the Compare AWS Support Plans page, you see that there's 4 levels of support that we can utilize. There's Basic, Developer, Business, and Enterprise. Now, what we're really interested in here, the most important aspect of this, is actual technical support. Notice that with the basic plan, we get none. Interesting. So no tech support. You can't make a phone call or an email to a tech support representative at Amazon Web Services. No wonder why this is a free tier of support. Notice the developer level is going to give us business hours with access to cloud support associates via email only. The business plan gives us 24/7 access, and it opens up to email, chat, and phone. And finally, the enterprise level of support would give you 24/7 access via email, chat, or phone, but this time it's to senior cloud support engineers, the very best and brightest when it comes to solving problems at Amazon Web Services. But beyond technical support, there are excellent free resources available to us to assist us when it comes to properly designing and implementing our Amazon Web Service security. So here I've done a Google search on AWS Cloud Security Resources, and the very first non-ad link in Google is Cloud Security Resources for Amazon Web Services. Spend some time here. You're going to really be impressed with the developer documents around various areas of security, white papers, which are superb. I like to download these and put them on my Kindle for reading when I'm traveling or just sitting waiting for an appointment, and then articles and tutorials. These tutorials are superb, guiding us step by step through key best practices, for example, using Amazon S3, that's the storage service of Amazon Web Services, and as you might guess, this is going to be slanted towards the security procedures that we're going to do. And then there's also a link for the AWS Marketplace security products. Remember, there are great software tools out there that we can spin up in the cloud that are going to help us secure our cloud. So the Cloud Security Resources Google search is going to be our best friend in this area of additional security resources for support. Now, I don't know about you, but one question that I have at this point is what about documentation? I just need straight up documentation on a feature. How would we get to that? Well, notice I am not even logged in right now. So we're at the aws.amazon.com site. We're not logged in. Over here on the left is a menu, and look at this. The documentation is freely available to all. Gotta love it. So if I go down to the documentation link here and then go over here, I could go to a specific area of security that we need help with. For instance, what if we really need some guidance on identity and access management? No problem. We go to Security, Identity, and Compliance, and then we go up to IAM. We click it, and look at these incredible resources. There's a user guide, so super friendly, kind of intro, if you will, to the technology with step-by-steps on how to use it. There's a section of the IAM area for the command line reference. So if we want to start managing the security services of IAM from a command line interface, so this is great for like scripting automation. There's a reference of all the commands we can use. If we're going to develop software that handles IAM for us, we need an application programming and interface reference. That's what this is. Then we have a STS section of the AWS CLI reference, and also an STS API reference. What is STS? This is the security token service. One of the things that we have with security is a user will possess a token that defines their rights and privileges in the Amazon Web Service system. So this is very advanced security, but once again, it's great that we get free documentation on it. In this nugget, you and I toured some of the resources for security support with Amazon Web Services. Notice these would apply to other areas as well, not just security. The one specific area we looked at for security was those cloud security resources. But when it comes to the levels of support that we discussed, that would be, of course, for more than just security problems. And also, when you're using the documentation, that's going to be beyond the scope of security as well. In these videos where I cover support resources for you, I'll be touching on different ones that are certainly going to have applicability to many different facets of your cloud design and implementation. I hope you found this nugget informative, and I'd like to thank you for viewing. As you start moving more and more of your IT infrastructure to the cloud, you're probably going to need more and more guidance. In this nugget, I'll show you resources centered around technology support. These are going to be in addition to resources that I've already shown you, for instance, when we were looking at the security resources that are available. One of the most powerful resources for any area of technology that you're working with in Amazon Web Services is the frequently asked questions documents that Amazon engineers spent so much time crafting. If you're wanting to go beyond the cloud practitioner area and you're wanting to go into deeper levels of Amazon Web Service certifications, these tools are critical because many of the exam questions that you would face are written directly out of these FAQs. Let me demonstrate this. So I did a Google search here on AWS EC2 FAQ, and the very first link brings us to the frequently asked questions area for EC2. Notice there's so much to Elastic Cloud Compute that we get a whole bunch of different categories in that one subject area. So for example, if I'm struggling with the concept of what an elastic IP address is, I can jump right to that section and I can read the frequently asked questions that Amazon gets on this subject of elastic IP. Notice that oftentimes there's going to be links inside of the FAQ to bring you to the appropriate portion of the documentation or even the appropriate section of the management console so you can begin working with that resource. But here's something to think about. What if you have a pressing question that is not answered in the frequently asked questions? One thing you can consider doing, especially if you don't have a support contract with Amazon Web Services that gives you access to technical support, is go up to the menu and underneath supports and services, you can sign up for a free account up at the Amazon Web Service discussion forums. These are heavily moderated forums, very professionally done, and you can read the rules and ask your question in the appropriate forum. And my experience has been you're going to get at least a response very, very quickly. Oftentimes, if your question is super interesting to the forum viewers, then you'll get a whole bunch of responses and learn a lot in the discussion that ensues. A great free resource that's available to us for getting support. Now, the last resource I want to discuss with you here is that rare situation where something just isn't working. You might be getting some cryptic error message when you try and access a service, and maybe you know you can access it because you did the previous day. There is something to consider, and that is that Amazon Web Services might be having problems in the region you're trying to operate within. That's why Amazon does a great job of providing us with this resource. Watch. I'm going to go to the menu, and under support and services, notice there is a service health dashboard that is made available to us. So for each of the areas of the world and the regions inside those areas, we can check for problems that a service might be experiencing. Notice we can also open our personal health dashboard so that we can see issues that might be impacting us directly for the regions of the world that we are operating in. So I'm lucky in the last 7 days, there are no open issues in any of the regions or the availability zones that I'm currently hosting resources in. In this nugget, we examined 3 more additional resources that we have for support, and all of them were free, weren't they? We had the frequently asked questions that are available for us and categorized for easy lookup of just I really find them interesting to read, even if I don't have a question about a service. I love to go in and look at the FAQs. We also discussed in this nugget the ability to register for a free account up in the support forums and to be able to post and even share our knowledge with others in those forums. And finally, we saw that there is a service health dashboard, even one that's tied to our account called our personal health dashboard, where we can check for issues that Amazon Web Services might be having. Amazon's very proud of their uptime and their reliability when it comes to services, so don't be surprised if it's very hard for you ever to find an entry in those dashboards, and that, of course, is a great thing. I hope you found this nugget informative, and I'd like to thank you for viewing. If you're one of those that's interested in taking the Cloud Practitioner certification exam with Amazon Web Services that coordinates to this course, get ready to see lots of questions about security. This is because Amazon Web Services is super excited about the security they can offer you, and security is a major concern for people when it comes to move to public cloud. Now, we've talked about security quite a bit already here. For instance, we discussed with you the shared responsibility model and how great that is, where Amazon Web Services is taking care of doing things like going in and securing many of the internal components of your virtual private cloud for you. So they're taking care of doing this intense physical security on the hardware that makes up this equipment, as an example. But also we've discussed things like identity and access management. When you go to services and you go into the security category, notice the very first one listed is that foundation of identity and access management. And this is where we can define the groups and users and roles and policies. They're going to make up what people can do when it comes to working alongside of us when it comes to setting up the Amazon Web Services that we need. Not easy for me to say, clearly. So now let's expand on that a little bit, though. Security is very, very far reaching. For instance, when you go into your services and you just pick almost any one of them at random, we'll just pick EC2 for virtual machines, notice there is going to be a security subsection here. So there's security groups that are going to control access into the VM and out of the VM when it comes to interacting with the virtual machine and sending traffic in and out. Notice there's going to be elastic IP addresses, which are going to definitely impact security because you want to make sure that when you contact these elastic IP addresses for your resources, you're doing so in a secure manner. There's going to be key pairs that are going to make sure that you securely connect and have a secured key that you use to connect to that resource. So lots of different security mechanisms that make their way through all of the services of AWS. So this brings up an interesting point. Security can get super complicated because there's so many moving parts. The good news is Amazon realizes this and gives us a great tool to assist us. I'm going to go to services here. And you know what? Instead of searching for it, I know where it is. If I scroll through the list here and find management tools, under management tools is a great product called Trusted Advisor. What the Trusted Advisor will do is it will look at your infrastructure and tell you if there's any problems that you're clearly having with cost optimization, or any problems that you're clearly having with performance, or security, or fault tolerance, or service limits. Are you getting close to having too many resources in a certain category? Notice, sure enough, we're having a security problem, and it tells us exactly what that is. We have a security group that is not restricting things down to specific ports, or in my case, the issue is this SG Management Linux security group is open to the world as far as IP addressing goes. And notice there's a link right in here so we can jump to that security group and check it out. So here is that security group. And if I look at the inbound security rules, the issue here is I'm allowing just SSH in. That's good. But the problem is I'm allowing that access from any IP address in the world. And Amazon Web Services is rightly saying, Anthony, lock that down just to the IP addresses that you would actually be using at your company to come in and interact with this, in this case, the virtual machine that this security group is associated with. So the Trusted Advisor is going to be a powerful tool in our back pocket when it comes to improving lots of things in Amazon Web Services, and that definitely includes all those sticky aspects of security we need to work with. So what's the foundation service when it comes to security? Well, it's definitely IAM, or Identity and Access Management. But we know that there's many different security components, security groups, network access control lists. There's many different components sprinkled throughout the services. One of the things we looked at also in this nugget is the Trusted Advisor to help us make sure that we are doing the very best we can when it comes to security. I hope you found this nugget informative, and I'd like to thank you for viewing. In this nugget, I want to show you 3 of the core storage services that we have in Amazon Web Services. When you're building something like an EC2 instance, you need storage for that virtual machine. It needs a virtual hard disk where it can have the operating system stored and the data files that are being created inside of that virtual machine. This is something that Amazon created elastic block storage for. So it looks just like a real hard disk. Watch this. If I go into the EC2 console and we launch an instance, let's launch this Amazon Linux instance. So I'll select it. I'll say for an instance type, we want this T2 micro. That's fine. I'll just accept the default instance details. Notice the fourth step is for you to add storage, and it is adding a new root device for us of 8 gigs in size, and it's even using a nice SSD, a solid state disk, for great performance. And this is that simple to create. Notice that this virtual disk is created for us. We can resize it here, and we could even resize it later on if we need it to be bigger. So elastic block storage is certainly a foundational storage component for us. But there's another great storage component, and that is listed under storage in our services, and it's called S3 for the simple storage service. These are buckets that you can store objects in. So notice right here, I have an AWS networking photos bucket, and if you go inside there, you'll see that I created these folders, and one is called miscellaneous photos from my Dropbox, and another is called miscellaneous photos from my OneDrive. And if you click on one of these, you can see the actual objects that are inside it. So there's this photo right here, 59129 JPEG, and if I can click on it there, which I can get details about that object. Notice there's a link to that object. If I click that link, it's going to fire open that image. Now, why that worked is because I have this object marked with public permissions. Let me show you. If we go to the permissions tab, you'll see that under public access, I am giving everyone read access to that object. So that's why I was able to use that link in order to see that object. If you don't give public access, then you better be truly trying to reach out to that object with a user account like up here that has read permissions for that object. So the S3 storage buckets are great for object-based storage. But there's one more storage component that I want to show you. So I'm clicking the back button in my browser to go all the way back out. We'll go to our list of services here. And the service that I want to talk to you about for storage is Glacier. What Glacier is for is archiving stuff that you are not going to access frequently, but maybe a corporate policy says that you need to hang on to the stuff for maybe 3 years. There's some kind of a record that our company says, I know we're not going to really need it, but we need to archive it for like a 3-year period. Glacier would be perfect for that. It doesn't give you quick access to what you're storing inside it, but it gives you access to it should you need it. Sometimes it can take hours for you to actually retrieve some object in Glacier. So again, don't think speed here, but think low-cost archiving of your data. So in this nugget, we examine 3 critical storage services of Amazon Web Services. The Elastic Block Store, or EBS, and this is going to allow us to create hard disks for our EC2 instances. That is one use of EBS and the primary one. Then we have S3, the simple storage service, where we can create buckets to store objects. And by the way, there's no limit to the size of a bucket. If your bucket gets massive, that'll cost you a lot of money every month, but there is no limit to what you can store in the cloud. And then finally, we had the Glacier service. The Glacier service is for archiving data. I hope you found this nugget informative, and I'd like to thank you for viewing. There are so many reasons that we might move to the cloud, and certainly one of those reasons is the AWS global infrastructure. We love the idea that thanks to Amazon Web Service facilities all over the globe, we can move resources right to the global markets that we want to service so that users can access our resources of the cloud very, very quickly. If we need a web server in France, no problem. If we need an application server in Oregon, no issue, thanks to the global infrastructure. Something else that we love is the fact that we can have great fault tolerance. If there is a part of the world that is unfortunately experiencing some kind of environmental problem, we can service our clients from another region of the world that's unaffected. So here's how the global infrastructure is actually structured. Let's take Oregon, for example. There is a region called Oregon. So the first component that we have is a region. Notice this is a geographical area. There's a region in the United States called North Virginia. This is one of the first, might even be the very first region they created. So there's two regions. Inside of these regions, we have what are called AZs, or availability zones. And this is something that we can leverage for fault tolerance right within a region. So we could locate resources here, and they would be separated by a good distance, and they would be using separate data center facilities. So we can have the high availability and the fault tolerance that we want, like I said, right within a region. As you might guess, all of this stuff is connected with high-speed, fault-tolerant links. So there's going to be great connectivity between these global infrastructure components of Amazon Web Services. Now, something else that we have, in addition to regions and availability zones, is we have edge locations. So let me label that edge locations. And what these are for is these are for delivering content out to the users that are near that region, or they could be all the way across the globe, but ideally they're fairly close to that region. It's for delivering content to them at a very high speed. Edge locations work with a specific service called, if I can spell it right, CloudFront. So CloudFront enables us to park or cache data inside of it and deliver it really, really fast via edge locations out to the users that want to consume that data. So when you think the global infrastructure, you think of a region, and then inside of that region, you think about availability zones, and then you can even think about edge locations. You don't have to use edge locations. This would be considered an optional add-on for your use of the global infrastructure along with CloudFront. But these are the three main components: the region, the AZ, and the edge location. If you're interested in certification, you would need to know what each of those components is. When you're in the web console, the management console for Amazon Web Services, notice there's a drop-down right up at the top that allows you to switch regions very easily with the click of a mouse. And when you are building your services inside of Amazon Web Services, so let me go into the EC2 service, and let's pretend that we're going to launch an instance, and we'll just choose this Amazon Linux instance type, and then go and choose the T2 micro type and say we want to configure the instance details. Notice that one of the things that we're able to do is place this resource in a particular subnet, and that subnet is going to be located in a certain availability zone. So right here I have subnet BF401DD6, and notice it is in an availability zone called US East 2A. This is the Ohio area, the Ohio region, that's called US East 2. And then they just tacked on an A for that availability zone. It looks like there's 3 availability zones in the Ohio region. There's A, there's B, and there's C. So that's how easy it's going to be to take advantage of placement of resources inside of these availability zones. I know, availability zones and all this is super interesting, and you're probably going to want to learn more about it. And I've got a great place for you to do that. If you go up to my blog, ajsnetworking.com, and you scroll down here, there's the ability to search. So I'm going to search on the word global, and I'm thinking the very first link is going to come up out of my Amazon Web Service category over here. And notice it's called AWS Global Infrastructure. Check this post out because I give you all kinds of interesting facts that I learned at the recent AWS reInvent conference in Las Vegas about this global infrastructure. I think you're going to love this article. So remember, the global infrastructure is going to allow us to take care of the placement of resources, so there's the lowest possible latency when our clients are getting stuff from our cloud. And then the other thing we love about it is the redundancy that we get, the fault tolerance that we get, the ability to locate resources that are geographically separate from each other as an additional protection mechanism. I hope you found this nugget informative, and I'd like to thank you for viewing. When we talk security in AWS, we really need to start with something that's critically important you understand, and that is that you are engaging with them in what's called a shared responsibility model. You see, what's happening is you're dividing up the security responsibilities with the professionals up at Amazon Web Services. To generalize this, we say that Amazon Web Services is responsible for security of the cloud, and we're responsible for security in the cloud. So they're going to be responsible for securing the hardware, for instance. One of the things that they'll also be responsible for securing is the software that runs on that hardware. So an example of this is when you have an EC2 virtual machine, they need to make sure they put the appropriate software in place so that some other customer's virtual machine on that same piece of hardware can't come in and get access to your virtual machine. They also are responsible for physically securing the data center in an availability zone that stores all your stuff. And they are superb at this, and they're using the latest, greatest technologies to make sure that their security of the cloud is top-notch and cutting edge. Great. So we get a benefit right off the bat with Amazon Web Services in the security of these areas. I hate to say it, but they're probably going to be better at securing a data center than we are. They have nearly an unlimited budget for doing so, and they've got incredible expertise at doing so. But notice we're not off the hook. We have to manage security in the cloud. That's our portion of the shared responsibility. So a classic example of this is when we do spin up a virtual machine, an EC2 instance, we're going to be responsible for securing the operating system that we place on that EC2 image. We're going to have to make sure we go in and do updates of that operating system, perhaps to keep it secured, apply the appropriate patches that are needed to keep it secure. And we also have to go in and configure the virtual firewall that is going to dictate security for traffic coming from that virtual machine and traffic going to that virtual machine. We implement virtual firewalls in Amazon Web Services through the configuration of something that is called a security group. A security group is a critical concept for us to master. This is the firewalling that we will do against that operating system, as I mentioned. So these things are our responsibilities, and this is certainly one of the reasons why Amazon Web Services isn't going to put IT engineers out of business with companies. There's still going to be the requirement for internal security experts to take care of security in the cloud with the Amazon Web Service tools. But again, it's going to be our primary responsibility for doing this stuff on this bottom portion of the slide. Now, fortunately, Amazon Web Services provides us really easy to use tools when it comes to our aspects of the security model. For instance, here we are in the EC2 dashboard, and you can see that one of the things I have for resources in EC2 is 2 security groups. And if I click on that link, I can see one of the security groups is the default that Amazon Web Service built for me, but then I created one called SG. I named it that for security group. Aren't I clever? And then MGMT Linux, the management Linux virtual machine that I have, I want to use this security group as its firewall. So that's why I named it that. Notice that I've selected this security group. And if we look down here, we see a very simple interface that shows us an overall description of the security group, and then the rules that are acceptable inbound. We can use SSH traffic over TCP protocol port 22 from any IP address into this machine. As far as outbound traffic goes, all outbound traffic is permitted. And we can see that this is a common setting of security groups, that we restrict things inbound, initially permitting nothing at all, and then we punch holes for what we want inbound, and then by default we permit everything outbound. You'll hear people that are against cloud technologies say that we are giving up security when we move to the cloud. But we know that's not true. As a matter of fact, we are leveraging the security expertise of Amazon Web Services because they are responsible for security of the cloud, and we still get to do our great security in the cloud. I hope you found this nugget informative, and I'd like to thank you for viewing.